Hi guys, this is section 5.7 and we are doing the second half of the lesson here, and we're going to focus on compositions now that we know some information about dead zones. And you should use order of operations when you are completing any of these problems, and that would tell us to work on our parentheses first. Do remember that our dead zones only apply to our inverse functions. So what I see happen often is then students will just come across a real straightforward sine or cosine question or something, and they're going to start thinking about dead zones. Be careful. Dead zones only apply to the inverses. So in example 1, we're being asked to find out the inverse sine, so that means we should be considering dead zones. And sine is good on the side. Remember our memory trick for that. The sine value is positive 1 at our top corner, so that happens at pi over 2. So the inside part of that parentheses set is replaced with pi over 2. Okay, and once you do that, you can forget about the dead zone stuff. Okay? Oops, I wrote an inverse here. Sorry. Should just be regular sine. I just replaced the parentheses part with pi over 2. Okay? And I'm being asked to find the sine of pi over 2. Sine of pi over 2, go figure, is at the top corner of the circle, and that is positive 1. So this is a problem in which the sine and the inverse sine kind of undid each other there, and you're left with the original input value. That happens sometimes, not all the time. I'll talk more about that in a little bit. Example 2 is sine and inverse sine again, but the order that I did them in is different. So the first thing we're doing is taking the sine value. The sine at pi over 3 would be here. That's a 30, 60, 90 triangle, so hopefully you've got that memorized by now. And that is positive root 3 over 2. All right, that takes care of the inside part, and then I'm done with that. Now I need to do the next part, which is inverse sine, and that means I should be thinking about those dead zones. Being asked to find the inverse sine of positive, well, that rules out quadrant 4, so we have to be in quadrant 1, and root 3 over 2 is going to happen at pi over 3. Okay, so here is another example of a problem in which we ended up with the original input value. Again, that doesn't always happen. For example, example 3, we're being asked to find the cosine of 5 pi over 4 first. That's the inside part of the parentheses. So that's here, and that is a quadrant 3 situation, and we know that quadrant 3 has negative cosine values, and it's a 45, 49, 45, 45, 90 triangle, so that tells us that it's negative root 2 over 2, and then I'm done with that inside part. Now I'm working on inverse cosine, and that happens to take account with those dead zones there. Cosine is good on the cap, remember, and cosine is negative where it's good only in quadrant 2. So the answer to this question is 3 pi over 4. So here is an example in which the cosine and inverse cosine did not undo each other, and that is because the angle we had was in the dead zone. Example 4, I'm going to start inside the parentheses. They're asking me to find the tangent of 3/4 pi. Okay, remember our memory shortcut for where things are positive. All students take calculus. This is where all trig functions are positive. The only one that's positive here is sine. The only one that's positive here is tangent. The only one that's positive here is cosine. Okay, so that means that tangent is negative there, and that means it's negative 1. And that's coming from the fact that it is sine positive root 2 over 2 divided by negative root 2 over 2. That's where that came from, sine over cosine. But we should know that at this point. Okay, and now I'm going to move on to the second part, which is taking the inverse tangent, and now I need to be worried about my dead zones. We're dead in that quadrant. So that means that's not going to be my answer. There is another quadrant in which tangent is negative, and that happens in quadrant 4. Now be careful. It's at this location, which could be called 7 pi over 4, but I will tell you that that is not the correct answer. And the reason that that is incorrect is because you had to pass through a dead zone to measure that. Okay, you pass through the lava. You cannot do that. So to get around that, what you're going to do is measure that backwards. And that means we'll name that as negative pi over 4. Yes, those are coterminal angles. We cannot pass through the dead zone, and that's why we have to do it that way. All right, so your textbook has a lot of information about how to memorize when the inverse compositions undo each other and when they don't. And quite honestly, I think it's just easier to take it on a case-by-case basis. Example 1 and 2, it was not in a dead zone, and that's why it undid each other, versus example 3 and 4 was in a dead zone, so that's why we didn't end up at the same spot. All right, one last thing we need to cover here, one last type of question, and it's similar, but what we're going to be doing, it's not going to be our special spots on the unit circle, and instead we're going to use a sketch to answer these questions. You do need to remember that sine is equal to our opposite over hypotenuse, and when we're talking about the circle, we could name that with y over r. Our cosine value is x divided by the radius. Our tangent value is sine divided by cosine, and that ends up being y divided by x. And then don't forget all the reciprocals of those as well. Okay, so starting in the parentheses in example 5, we're being asked to do the inverse cosine, and that means we'd be finding an angle. Now, I'm going to draw a picture of that angle theta, but I'm not actually going to find out theta's measure, and you'll see why in just a second. Also, did you notice that's an inverse? And that means that we need to take into account the dead zones. Cosine is dead down here. Cosine's good on the cap, remember? Okay, so given the remaining 2 quadrants we could use, the one in which cosine is negative is over here in quadrant 2. So draw a triangle there. It does not need to be perfect. It's just going to be in that quadrant. Cosine is x divided by r. So the x value is -1, and the radius is 4. That's the hypotenuse of that triangle. What we've done is we've identified the theta. Okay, just leave it like that. We're not going to find its angle measure. What I'm going to do now is move on to the next part, and I have to find the tangent of that particular theta. And the tangent will be the y value divided by the x. We already have the x value. We don't have the y, though. We're going to have to find it. And you can do that using Pythagorean's theorem, unless, of course, it is a Pythagorean triple. So that's going to be 16 minus 1, or root 15, and it's positive. That's the y value. So root 15 over -1, which leaves my final answer as negative root 15. So I didn't actually have to identify the angle measure in radians to answer this question. So on these use a sketch questions, you're just going to draw a triangle in the appropriate quadrant. Let's do one more like that. Starting inside the parentheses, this says inverse sine. Sine is dead on the side here. And it's positive 5/13. That tells me that we're in quadrant 1. Draw a triangle, does not need to be perfect. Sine is y divided by r, so 5 and 13. That is a Pythagorean triple, so that means that this side is 12. It's positive 12 because it's in quadrant 1. And if you don't have that memorized, that's no problem. You'll just do Pythagorean's theorem to find that. So what I've done is I've identified the theta. And now we're going to move on to the next part, which is finding the cotangent of that theta. If tangent is y divided by x, that means cotangent is that reciprocal, x divided by y. And I'm simply just going to use the things that we just labeled here. X is 12 and my y is 5. All right. So that's it for section 5.7. Nice job, guys. See ya.